My name is Chaitanya, Physics faculty at Shri Shakti International School. In this video, we are going to learn about an important topic of Newton laws of motion from class 11, that is Apollo system. In Newton laws of motion, we analyze the force and the effects of that force. That means if an object is moving, we are going to analyze, basing on the mass of the object, what is the acceleration produced in it and different kinds of forces which are related to its motion. In this pulley system, we use a massless pulley. Okay, an ideal pulley, make sure you remember these points. An ideal pulley is always a massless pulley, okay, and without any friction. Now, over a pulley, we are going to use an ideal string. An ideal string is always inextensible and massless. So now, let's say two objects of masses are attached to this string. Pulley cannot increase or decrease the tension in the string, but it can only change the direction of that force. Okay. Now, since these two masses have experiencing the gravitational force, acting on it. Let's say this is m1 mass, this is m2 mass. Both the forces are acting in downward direction. Now, in the upward direction, the tension will be developed. And remember, tension is the force that is being developed when a force is exerted on a string, and tension always will be acting away from the object. That means towards the point of suspension. Always remember, in a same string, if it is the same string or rope, tension will always remain constant. Tension will be same everywhere. Now, if we are considering this object as A and this object as B, okay, on object A, if you are drawing free body diagram, the forces acting on it are tension T and m1g in downward direction. And if I am drawing the free body diagram for object B, the forces acting on it are tension T in upward direction and m2g in downward direction. Now, consider, let's say, if m2 is greater than m1. This is one condition. Let's say this is case 1 we are analyzing. Okay, if m2 is greater than m1, then what will happen? Then object should be starting moving in this direction. This is the direction it will be moving. Let's say it is moving with an acceleration a in downward direction. If it is moving in downward direction, that is m2 mass is moving in downward direction, m1 mass should be moving in upward direction with the same acceleration but the opposite direction. Now, that means this is going in upward direction with an acceleration a, this is moving in downward direction with an acceleration a. If you are trying to write an equation for this one and for this one, okay, since acceleration is an upward direction, what do you mean by it? We are using the second law of motion, that is F net is equal to mass into acceleration. The net force acting on this object, that is object m1, object A, is tension minus m1g. Why I am writing tension minus m1g should be equal to m1 into A? Because tension force in this condition is greater than m1g. Because that is the reason why object is actually going in upward direction. If m1g is greater than tension, then it should be going in downward direction. Since we know m2 is greater than m1, m2 is going to pull the m1 in upward direction. So that is the reason why we are taking tension minus m1g to be m1a. So if you are writing in this equation, writing equation for this object, then you can write m2g minus tension is equal to m2a. The major differences in this is m2g is greater than tension. So now we are having two specific equations. Now, whenever we are having two different variables, we need two different equations. Tension is a variable and acceleration is also a variable. We have to find these two variables. We got two equations, we have to solve these equations. So if I am writing T minus m1g is equal to m1a and minus T plus m2g is equal to m2a. So these two, if I am adding these two equations, these two tensions will get cancelled. You can write m2g minus m1g is equal to m1 plus m2 into a. So finally, giving a resultant of acceleration to be m2 minus m1 into g divided by m1 plus m2. In this condition, I am taking m2 is greater than m1. Make sure you are remembering the formula. If m1 is greater than m2, then the formula of your acceleration will be m1 minus m2 divided by m1 plus m2 into g. Now, if m1 is equal to m2 in this condition, if m1 is equal to m2, this is if m1 is greater than m2, then acceleration will be 0. That means they will not be moving, they will be at rest. I hope you are able to understand these two different conditions. Now we have known what is the acceleration of the objects. Using the equation of acceleration, that is m2 minus m1 divided by m1 plus m2 into g, we can find what is the tension. So tension equation, if you are substituting the equation 1, then T minus m1g is equal to m1a. So you can substitute T minus m1g is equal to m1 into, in place of acceleration, m2 minus m1 divided by m1 plus m2 into g. Into minus, okay, I have substituted the acceleration. This will be the equation. Now we have to solve this equation. So we know into g is there, sorry, yeah, that's what I missed here. Okay, so m2 minus m1 divided by m1 plus m2 into g. So tension T can be written as m1 m2 minus m1 square divided by m1 plus m2 into g. Minus of minus, when it is coming here, it will be plus m1g. If I am taking m1 common out of this equation, then you can write T is g common out of this equation, g into m1 m2 minus m1 square plus m1 into m1 plus m2, since I have to take LCM, divided by m1 plus m2. So now further, if you are solving this equation, tension T is equal to g into m1 m2 minus m1 square plus m1 square plus m1 m2 divided by m1 plus m2. Cancel these two m1 squares. Finally, we will be ending up with a formula, that is tension T is equal to 2m1 m2 divided by m1 plus m2 into g. So these are the different equations we are getting in case of pulleys when it is vertically hanged. So in this case, we got two important formulas, that is acceleration A is equal to m2 minus m1 divided by m1 plus m2 into g, and tension T can be written as 2m1 m2 divided by m1 plus m2 into g. I hope you got these two equations. And if any problem, let's say if I am giving an example problem, we are having two masses of 3 kgs and 5 kgs attached to this pulley. If you want to find what is the tension in this and what is the acceleration, we can substitute directly in this. Acceleration you will be getting by 5 minus 3 divided by 8 into 10. Tension you will be getting as 2 into 3 into 5 divided by 8 into 10. So calculating this, you will be getting 2 by 8 into 10. This will be 3 into 5 into 10 divided by 4. So calculate this, you will be getting your final output of acceleration and tension. Hope you are able to find, you got this equation. If you will be able to use these equations. In this there are different other conditions also. In any condition the logic is simple. F net acting on the object is equal to, another example you can take it in this form also. Let's say there is a surface, an object is kept on this, there is a pulley here, this object is attached to another object B. This is your object B and this is object A. This is a frictionless surface. Coefficient of friction is 0 if I am giving. Then it will have m1 mass, let's say. This is having m2 mass, let's say, in this equation. The tension T developed in this will be in upward direction here, and the tension will be in this direction towards the suspension and always away from the object. Okay, so this will be written as m2g. Okay, if they both are at rest, if they are in equilibrium. Let's say if m2 is greater than m1, okay, then m2 will pull the object m1 in downward direction. So T will be greater than, will be lesser than m2g. In that condition, you have to write m2g minus T is equal to m2a, and on the m1 object the forces acting on it are T. T is equal to, you can simply write it as m1 into the acceleration that it is actually moving, because they move with the same acceleration. Okay, because no other force is acting on it. We do have weight and normal forces cancelling each other. This is a normal force, these two cancel each other, so you don't have to bother about a vertical force, only horizontal force you have to take care. So now you know what is the tension, you can substitute in this equation. So you will be getting m2g minus of m1a is equal to m2a. So finally equation of it will become m2g is equal to m1 plus m2 into a. So acceleration A can be written as m2g divided by m1 plus m2. This will be the acceleration. In the same way, tension, you always have tension, you can substitute the acceleration in this equation. You can get it m1 m2 into g divided by m1 plus m2 is what the equation. I hope you understood the different cases of it. Okay, thank you.